I want to say welcome to Kathleen Baskin from the Massachusetts Department of Environmental Protection. She's going to be talking today about the effect of climate change on water resources. And we're so glad you could be here with us today. And well, stop that. And now you should be able to share your screen and do your slides.
Great. Okay. And let's see. Open around here. All right. Well, thank you so much for inviting me. I love the Envirothon. It's a great opportunity for me to engage with students on topics that I feel passionate about, and fingers crossed, hopefully we'll develop some new environmentalists out of the experience. So I'm going to talk about how climate change affects water, but I'm going to talk about it from the hydrologic cycle. So we have all heard about the hydrologic cycle, and what happens is, we've got the normal pattern of water that's say on the ground or in the soil, and it's evaporated or it's taken up by plants through evapotranspiration. Eventually goes up into the atmosphere where it's held for some time and then comes down in the form of precipitation, rain or snow or ice. And some of that will run off directly as stormwater, and some other amounts will come down into the ground, percolating into the ground and providing basically the base flow or the lifeline for a river when there is no rain. So, how do rivers flow when we have no rain? They draw their water from the groundwater, where the water is already percolated through the soil and is available to the rivers. So the thing is, if we start with this hydrologic cycle and then we increase the temperature, things really change. So that's what I'm going to talk about today, is what happens when you increase the temperature and you have this hydrologic cycle that we're all accustomed to. Things start changing. And that's really, if you talk to people about the climate or weather, people will say, oh, well, it's not like it used to be, or we used to have more snow when I was a kid. Or they might say, oh, I can't believe we had another 100-year storm and it's only been a few years. So I'll talk a little bit about some of those ideas that people are noticing, but they haven't quite articulated where this is coming from, what's happening. So when you increase the temperature in the atmosphere, you get some impacts to how water is delivered to the earth. And then this, of course, affects all sorts of other water resources that you're going to hear about in other presentations for the Envirothon. So you may hear about water resources with respect to wetlands or drinking water supplies or wastewater or green infrastructure and using nature-based solutions to capture and treat stormwater. This is more about how the water from the sky actually comes in a different way and causes disruptions to those different types of resources that you may have already heard about with stormwater, wetlands, water supply. So what happens when you increase the temperature? Well, first of all, you're going to get more water coming out of the earth. So more is going up into the atmosphere, more evaporation from our water bodies and more evaporation from the land. Okay, so you have more water up in the atmosphere, and the warmer air holds the water for longer. So there's more of it and it's staying up in the atmosphere longer. So when it finally does come down, you're going to get a lot more water or a lot more precipitation than you had in the past when temperatures were lower. the other thing is, because you're holding the water, the atmosphere is holding the water longer, you're actually seeing more periods of drought. So the water is getting pulled up into the atmosphere and held longer, and there are longer periods of dryness back down on the earth. And when it comes, we're not prepared to handle it all. So we're getting more intense rainstorms, which cause more flooding. We haven't, our systems, our natural systems and our man-made systems weren't really designed for these higher intense rainstorms. And certainly we haven't designed our society for more intense droughts. The other thing that we see is that with the higher temperatures, even the way we get our precipitation when we get it is in a different form sometimes. So for example, the country, and especially the Pacific Northwest, but also northern New England, rely on snowpack for our stream flow. So that snowpack, when it snows and the snow is sitting there for a period of days or weeks or maybe even a month or longer, it's being held for a recharging into the ground later on. So it's hanging out there, it's ready to recharge, but obviously the temperatures haven't warmed up enough, so it hasn't turned to liquid, so it hasn't come into the ground yet. But it is available for a time when our streams and our fisheries, aquatic habitats, are used to seeing this stream flow. So where our systems are based on seeing increased stream flow in the springtime. When I mean our systems, I mean our rivers, our fisheries. So the increase in stream flow comes in part, some comes from rain, but some of it comes from the snow melt. But if you have a warmer winter, which actually we're seeing, as temperatures have increased with climate change, actually the winter season has increased more than the other seasons. So we have warmer winters, and our precipitation is being delivered more often as rain or perhaps as ice, but not snow, which is sort of like money in the bank for later on in the spring when our rivers are expecting that spring flow. The other thing about receiving precipitation in the winter in a different form is you could have ice storms. And we saw a huge ice storm 12 years ago. I have a slide about that in 2008 that caused a lot of damage and power outages for 2 weeks. So that was in Central Mass. And so let's talk a little bit more about some of these effects. So all of these are all related to the increase in temperature and the changes that occur when you have, when you apply the temperature to our hydrologic cycle. So let's talk a little bit about climate change and what we know has already occurred because we can measure it. And so we do know, for example, that we've seen the increased temperatures in the Northeast. And that includes Massachusetts, of course. Since 1970, so for the past 50 years or so, we've seen an increase in up to 2 degrees Fahrenheit. But the winters we've seen up to 1.3 degrees Fahrenheit increase per decade. So we've seen quite a bit more in the winter. And like I mentioned, we're experiencing a decreased winter snowpack. The flowers are blooming earlier, and they're more extreme. We have more extreme summer heat. So when we talk about heat wave, that is a period of 3 days where the temperature is 90 degrees or higher. And we're seeing more heat waves with climate change. So we have been able to measure. So people dispute climate change sometimes. And I always like to start with the data. What do the data tell us? What do we already know has occurred? So the, two ways to look at the climate change. First is, what have we measured? And then what's projected, or what is modeled based on what we know about carbon emissions and existing conditions. What do the models tell us? So I'm starting with, what have we measured? What can we not dispute? And another thing to take a look at is changes in annual precipitation. And this is a really tricky one, I think, because you can see since 1818, the changes in precipitation have been, there has been a huge swing up and then down, and then we're starting up again. And that little chunk of where we're starting up again is over on the right-hand side. And that shows you the last 60 years or 50 years or so of data where we're starting that incline. So on an annual basis, we're not seeing a huge difference. But what we are seeing, so this is like the total amount of rainfall over a whole year. Used to be 40 inches, now it's more in the 50s. That's not the headline, though. The headline really is around how the water is delivered. So over the year, we're going to get about the same amount, give or take, maybe a little bit more. But how it's delivered, in what kind of increments, those big storms with then big gaps for droughts and then more big storms, that's really the big news. And so just showing you a little bit more about the country too, and how we've experienced changes in precipitation and the water cycle. So the U.S. Geological Survey is an agency of the federal government they do science. They're all scientists, and they're out measuring water quality, river flow, groundwater elevations. And this is a graphic that was done by some of the folks in New England, or included some New England folks. And what it looks at, it compares more recent data, so the period between 1985 to 2014, to older data, 1945 to 1974. And so they're taking how much rain do we get now versus how much rain did we get before. And if we're getting more now than we did before, the area shows up blue. And the areas that are red are getting less water than they used to get. And so you can see this shift in precipitation over the country, where you've got the Florida, Georgia, the Carolinas, Northern California, Oregon, Washington, out on the West Coast. They're getting less rain, less precipitation than they used to. So who's getting it instead? Because, I showed you the total amount generally is not changing, but there is a little bit of an increase. And this little bit of an increase is being reflected in that blue that you see in Massachusetts and the New England area. So we are getting more than we used to, and there are other places that are getting less. The other thing that's interesting too about this, the same is true if you took Massachusetts and stretched it out over this graphic, you would see changes, on, for example, projections, what you would expect in the future. It's not all constant throughout Massachusetts. And I can talk a little bit about that when we get into the projections. So this gives you a little bit of an idea of, who are going to be the winners and who are going to be the losers with respect to water. Frankly, I would like to be where we are, where we're still getting the water, and we'll be assured that we get the water we need. But we're going to have to figure out how to manage that water, because we're going to get it in different amounts and different frequencies. Let's see. This should just switch, and it's, oh, there we go. Okay. All right. So one other thing I want to talk about with respect to what have we already measured, and that is this thing called the 100-year storm. Oh, whoops, here we go here. The 100-year storm is, did I lose you on my PowerPoint?
It's gone back to the
Okay,
show
let me just
screen,
flip
but
it back. Sorry. Yeah, I don't know what happened there, but I think there was a link that was built into the into that. So let's just go back to, here's where I want to be. Okay, sorry about that. All right, so a lot of people talk about the 100-year storm. And so what is that? And what's the significance of it? Well, first of all, it's not even the right name. It's really called the 1% chance storm. So that is, on average, that huge storm that's likely to occur once every 100 years, or only has a 1% chance of occurring in 1 year. And so it's a theoretical storm, but they do occur, and they're significant because design storms are what are used. So this is called the design storm. We also have 10-year storms. We know what the 2-year storm looks like, and engineers use these storms to develop their infrastructure. So they might say, we need to have a pipe that can convey water from a 10-year storm. Anything beyond that will flood, and that's okay because we know where the water is going to go and we can manage it. Or we're going to build a huge stormwater basin that will manage the pollutants and the volume of water, and we're going to design it to accommodate a 1% chance or a 100-year storm. So this is how engineers figure out how big to make something. And the actual description of a 100-year storm has changed over the last 60 years. So in 1961, our federal government looked at all the history of rainfall data and said, okay, that 1% chance storm is the one that occurs that lasts for 24 hours, but only has a 1% chance of happening in a year, is 6.5 inches. And what happened, though, is over the last 50 or 60 years, there have been huge changes in our precipitation. And that 100-year storm has been revised to 8.4 inches now. So when we talk about designing something for a 100-year storm, we're actually a little stuck right now because we're shifting our regulations over to catch up with reality. And what we're finding is that we may not necessarily have a properly sized pipe or stormwater basin or other types of infrastructure because we didn't know that the 100-year storm was going to increase by 2 inches. And 2 inches doesn't sound like a lot, 2 more inches of rain. But if you put that 2 inches over the whole landscape of where you're trying to manage, so maybe you're thinking about managing a 5-acre site, and you add 2 inches of water over that whole site, all of a sudden you have a lot more water that's coming, all draining into your catch basins or your stormwater basins, or you're trying to infiltrate it, you're trying to make sure you're not flooding the neighbor. That's a lot of water to manage. So this is considered a really huge increase in the amount of precipitation. And the other thing is, people will say, oh, we just had another 100-year storm. It feels like we have them all the time. Well, really, the old 100-year storm is now more like a 25-year storm. So that means it has a 4% chance of occurring in a typical year. So, and here are a couple of notable slides that, you may not even remember. You're in high school. This was 14 years ago. But here is North Andover, and they're, taking the fire department's taking a boat to rescue folks who experienced some significant flooding. This is the Mother's Day flood. And here's another one on Mother's Day flood. You could, take your boat right into Friendly's perhaps, or out onto the highway. So, the flooding really can be significant. And this is what a 100-year storm looks like. It's huge. So we want to make sure we know where that water is going to land. We want to make sure that we have the right properties insured. The federal government cares about where rainfall lands and where the flooding occurs. And they require that property owners have certain flood insurance to protect themselves. So this is all really important in terms of not just worrying about what's coming from the sky, but how it affects what's down on the earth waiting to receive it. So now let's talk about predicted climate change. And so we just saw what was measured, or what we know actually has occurred, those changes over time. Now, what are we expecting based on models? So there's some really good work that I want to make sure anybody who's participating in the Envirothon knows about, and that is the work that is on, and I do have in my last slide the link to Resilient MA, all one word, dot com, I think, but .org. Well, I'll check that. So there are projections there for watersheds, for counties, and for the whole state. And so this gives you an idea of where we're at today, our average temperature. So the average temperature for each of these years was 47.6. So you take all the 365 days in 1971, get the average, and then average that with all the days of 72, 73, 74, up to 2000. So that's where 47.6 comes up. And then the average maximum was 58. So the projection, the change that we're expecting based on our climate scientists, and this was done by climate scientists at UMass Amherst. So they have a really great program there, the Northeast Climate Science Center, that's funded by the federal government, and they've made some incredible contributions to the science around climate change, especially in Massachusetts. So they're projecting that there could be between 2.8 and 6.2 degrees more added on average to each year. Or if you look at the end of the century, up to almost 11 degrees more. That doesn't sound like a lot when you're talking about the average is 47.6. But keep in mind, the average is a smoothed out version. You have lots of days that are much higher than that. And if you're adding 10.8 on top of those higher days, all of a sudden you're getting some really warm temperatures. So for example, if you look down here, keep in mind that a heat wave is defined as 3 days with temperatures over 90 degrees. So on average, between 71 and 2000, we would get 5 of those days. And they were not necessarily consecutive. They were just on average that many days in a year. If you're looking at the end of the century, you could have up to 2 months of days over 90 degrees. So that's like the whole summer, really, July and August. And if you look at days over 100. Right now, we rarely get any, or up through 2000, very rarely, but we could have as many as 13. It's unclear. There's a range there, and that's because the climate science isn't determined yet. We don't know what pathway we're on with respect to the emissions. We don't know. Normally, if you do modeling, and so this is all projections, what you think will happen, you're able to put your projections in and tie it back to something that you already measured. Like, say you're doing, well, okay, we have this river, we're gonna put this pollution in, and here's the concentration of pollution in that river as a result. And we can compare our model results to actual measurements to see how off or how close we are and help calibrate the model. In this case, we can't really do that because we're projecting out into the future. So we have certain things we know about how the climate behaves and about what's going on with respect to greenhouse gases, but we don't know everything about what's happening in the future. And so that's why you see the ranges. Then the other thing here is days with temperatures below 32 degrees. So conversely, while we're seeing more days with warmer weather, that means that there will be fewer days with cold weather. And that's what we're seeing here. So we see up to, oh, this is a typo, so sorry about that. That should be 40, not 404. And I can submit a revised presentation there, but that is, but this number here is another 2 months. So while we're getting heat waves for 2 months in the summertime, we're also losing our snow because it will be warmer than 32 degrees for 2 months in the wintertime. So that's really quite a difference in Massachusetts. And this is what it looks like for average projected temperature. So the models, this is not the measurements anymore. This is what our models are telling us might happen. And you can see that there is a projection that will definitely increase. And I love this graphic because it sort of gives you a real life perspective of what it might feel like if you were in Massachusetts. And for example, it was between 2040 and 2069, it might feel like you lived somewhere in the Virginia area or so, or it might feel like you live in South Carolina if climate change goes the way it's projected and the year is somewhere between 2070 and 2099. So that's just gives you a sense of what it might be like in Massachusetts in the future, in your lifetime. Now, here's the thing about total precipitation. And I told you before, it's very hard to see that signal of a big change. So on annual basis, we haven't seen a lot of change. We're getting 45 inches, maybe in the future that'll be a little bit more, maybe up to 50 or 47, somewhat higher, but that is not the headline. This is the headline. So those storms that are bigger, 2 inches, 4 inches, that's where we're going to see more of them. So you can see it's starting to come up in those maximums, the ones that are projected to occur, those higher months, you're getting much higher peaks here. So we're expecting to see a lot more larger storms. And what we see there is you get the changes in precipitation. Not only do you have the floods from these big storms, you're getting the higher winter flows and flooding, earlier peak flows because you're not getting the snowpack, but you're also seeing an extended period of drought. And, one thing to keep in mind here, with respect to drought, low stream flows, is that there is less water in the rivers to accept the stormwater pollution, to accept the pollution that's discharged by a wastewater treatment plant. So in the summer, when there are lower flows, because there are more droughts and warmer temperature, more evaporation, you can have some water quality issues in rivers and streams that we don't see to the same degree that we might see in the future. So the other thing that goes along with the more extreme rainfall is the more extreme droughts. And you can see that the climate projections here are those maximum dry days. And this is consecutive. This is how many days in a row are expected to have no rain. So that's what we're seeing here. So, if you look on those maximums, if you follow the spread part, in this area, it looks like you might have 16 or 18 days, couple weeks, a little bit longer, where there's been no rain, and then we get some rain. What we're projected to see in the future, though, if you go out, are some years where we could have, another week of no rain, and that doesn't sound like a lot, but it can really add up, and it can be a huge impact to a system. Or you may see, if you get year after year with these long periods of, 20 days before the next rainstorm, that we're asking a lot out of Mother Nature to adapt to that. And not just Mother Nature and stream flows and aquatic habitats, but also the integrity of our water supplies. So we expect that we're going to have water in our reservoirs, that we're going to have water in the drinking water wells that serve our communities. But if we have rainfall deficits or longer periods of dry days, right as things are starting to run out, we may not be able to replenish them so quickly. And so, or we might have lower groundwater elevations. And so it's harder to get the water for the water supply. So these are sort of other impacts that arise as a result of the longer periods of dryness. And to combat that, our water suppliers are certainly accustomed to implementing water restrictions. So they're already working hard to do that, because there are a couple of things that contribute to water shortages. Climate change is certainly one of them. A lot of development in an area where people are watering their lawns, that would be another one. Or paving over the surface so that you're blocking that ability of the water to penetrate the ground and infiltrate into the groundwater, but instead creating stormwater runoff. So if the water hits the pavement and just runs right off, that water is really not available later on for nature or for water supply. So I think I mentioned the risks of drought with respect to water supply, rivers and streams, and also, of course, vegetation and food supply are impacted with water shortages. Here's a shot of that 2008 ice storm that I mentioned. And this basically shut down the central part of the Commonwealth for two weeks, where people did not have power. Electric lines were down all over the place. It was actually very unsafe. You can see this car, he's driving around and all these trees are down, but there are also places like that where there were power lines that were live that were, hanging down. So it was really serious. It led to a lot of changes with respect to how our utilities protect their systems against ice storms. And there are, so that's something that we're aware of, that there may be more ice storms because what used to be snow is coming down a little bit warmer and creating ice instead. And here's the projection for snow cover. So I always look at this and think, well, now I know where not to buy a ski condo. But seriously, this shows impacts to where we used to have snow cover, this whole red area, historically between 1960 and the 1990s, and what's projected through our models that will be covered by snow in the winter are just, a few areas in northern New England. And so, it's a serious impact. While somebody might say, oh, good, I'm going to have warmer weather, all of our natural systems are, expecting that things will stay the same. And so when, if we don't have a signal in the river to tell the fisheries that here's the flows coming down from the springs. So the flows have picked up because the snow melt has melted. This is time for fish to migrate upstream, for example. And then, they're expecting to have, some meals of certain insects. And maybe those insects aren't there at the right time because maybe they're not traveling at the right time because maybe the river isn't flowing the way it used to. There are cascading effects when climate changes and when we have a system that's delivering water in a different way. And I just thought I would throw this in. This really isn't about the water cycle, but I thought it was really interesting. And since I look at the trifecta of what I worry about with respect to the actors of climate change and what affects all other systems, I look at temperature, changes in precipitation, which we've talked a lot about today, and then sea level rise and coastal surge. And so this is another one of those things where we don't even have to argue about what's already occurred. This green line here is already what we measure. So we know that over the last 80 years or so, we have had about a foot of sea level rise out in Boston Harbor, out in the ocean. And that's due to a few different things. The sea has, or the ocean has warmed up. So, from your high school chemistry classes, if you take a liquid or a gas and you add temperature, the volume expands. So we've expanded the ocean. The other thing, there's been some other things in Massachusetts, in this part of the country, there are some glacial effects where at the same time the ocean is rising because there's some melting of Greenland because the ocean volume has expanded. We're also seeing that the land we sit on is sinking, it's subsiding. And that's because there was a big glacier here. So it landed on the land and the land kind of went down. And as the glacier melted, now the land is sort of receding. You can't see my arms, but it's kind of going down. So the land's going down, the ocean's going up. And what happens if you have a foot of sea level rise? Again, that doesn't sound like a lot, but it's huge. If you think about how cities were built around knowing where our coastline begins and ends. And if your coastline now can go up another foot into the elevation, into the landscape, that means that that's a higher platform for that coastal surge and the waves that come along in a storm to sit upon and then slam into, say, Boston downtown Boston. You've got the along New England Aquarium in that area. And these blue lines here are the projections. And what they show you is a range. So, like I said, the models are uncertain. There are lots of parameters that we don't know for sure about in terms of future climate change. So, for example, out at 2100, you see that the projection, if you look at 2100 right here, somewhere between 4 feet and about 10 feet is the projected sea level rise for Boston. And that's huge. And that is without Greenland melting. That's no ice, that is not ice sheet melting. That's everything else. So that's a huge shift and something that, the entire Massachusetts coastline is grappling with right now. So that's a sidebar. It's not really all about the water cycle, but I just thought I would mention this to you because I think it's really important. And there's a piece that is undeniable. It is actually has occurred. And then there's a piece that by all means, we're expecting sea level rise, and just it's a matter of how much might we get. And here's I don't know if you've ever seen these, but wicked high tides. So these are tides that already occur because of how the moon is situated. We get them a couple times a year, but you add something like sea level rise to this, or you add a storm on top of sea level rise and the already occurring wicked high tides, and you can have massive coastal flooding. So I spoke a lot about stormwater flooding and riverine flooding, and this is about coastal flooding. I think a few resources that you should know about. There's so many great resources online, and I know you'll find excellent tools that help you assess potential impacts, that review the climate nationally, the National Climate Assessment, for example, tools by the National Oceanic and Atmospheric Administration, all sorts of important stuff that's come out of Columbia University, for example. But there are a few different resources that are Massachusetts specific that I think would be useful to know. And so this is the first one, resilientma.org. So I couldn't remember before, but it is .org. And that is a really good clearinghouse. It has all sorts of information. So that has all these graphics, these things right here. I was able to pull those off of this Resilient MA website. But not only does it have graphics that give you projections, it also has important reports. And two of the important reports for Massachusetts are the Massachusetts, they call it the SHMCAP. So the State Hazard Mitigation and Climate Adaptation Plan. So the thing that's important about this is that the federal government, the Federal Emergency Management Agency, FEMA, has they are looking for hazard mitigation plans from states, from municipalities. It's a way for we have our own state, Massachusetts Emergency Management Agency, that does this planning too, where we look at what are the hazards that might occur in the state or in the community, and how can we best prepare. And this could be tornadoes and earthquakes, fires, but it also can be flooding, droughts, ice storms, things like that. So all these natural disasters that might occur. And then what might we do? What kind of projects could we take on that would help us avoid or mitigate those impacts? The thing that's significant about this report is that this is the very first in the country that's ever pulled in climate change and into the mix. So we're looking at natural disasters that could occur and how to avoid them, but also under the scenario of climate change. And that's really significant. And I think it's a really great document to look at. And also, a lot of the municipalities have been modeling their own hazard mitigation plans around this and pulling in climate change under a program called the Municipal Vulnerability Preparedness Program that the Executive Office of Energy and Environmental Affairs has. Hopefully you will hear about that amazing program that's available to provide funding from the state government to the communities so that they can do their own planning on how to become more resilient to climate change. The other document that I want to highlight that's Massachusetts specific is the first ever Massachusetts Climate Adaptation Report for Massachusetts. First and only. This is really more of a brainstormy document. So this one is a little bit older than the Hazard Mitigation and Climate Adaptation Plan, which has specific measures, but really goes into a lot of, I would say, almost the theory behind here's the climate change and what are the possible things that we could do. I think there are over 200 ideas there on first, what might be impacted and what could possibly be done. So it's not a plan. It doesn't say, oh, and therefore you're going to do this, and this is the schedule, and here's how much it's going to cost. It's more like we could do this, we could do that. But I think it's a really good place to get ideas about what possible impacts we might see, and also what measures could be taken. So those are my sort of helpful hints on what's available to you. And so thank you. It's really great to speak with you. And I hope that you have a really great experience on this project. I think it's an amazing topic, and I'm excited that the next generation is engaging on solutions to climate change. Thanks. I don't know if anybody has any questions. One thing that I was asked to, so the organizers did ask me to talk a little bit about my own background and who I am, so I can do that too. So I'm Kathy Baskin. I'm an assistant commissioner at the Department of Environmental Protection. So that's a state agency, and I oversee the government programs that protect wetlands, water bodies, make sure that drinking water is safe, that we have enough of it. We do testing of water, we write reports, we also tell polluters, wastewater treatment plants and others, how much pollution they're allowed to discharge. If they discharge more, we have the authority to go out and enforce against them and tell them that they've crossed the line and that they need to make repairs to the environment or perhaps pay a fine. And I can just give you a little bit of background more about how I got here. So, if you're interested in an environmental career, there are all sorts of ways to get into environmental work. You might be an attorney, you might be somebody who likes to write, and you end up writing for an organization that promotes environmental restoration, for example. Or you may be a math and science person and decide you really want to go into engineering and you really like calculations and figuring out how much filter media to include in a wastewater treatment plant in order to remove a certain amount of pollution so that when the water goes out into a river, it's clean. You might be somebody who likes to think big picture, and you're more into, you want to be a planner, think about the let somebody else figure out how many, cubic yards of filter media need to go into some treatment plant. I'm going to think about what the community is going to look like, where I might put some green infrastructure, and or you might be somebody who's interested in becoming a fisheries biologist, and you want to go out and see, are the right fish living in the river? Are the fish we are expecting actually there? And so there are all sorts of possible avenues into an environmental profession. And the pathway that I chose was that when I went to college, I really didn't know exactly what I wanted to do, but I knew I wanted to work in the environment. I started off as a biology major, and then I also included civil engineering, which I didn't even know what civil engineering was, to be honest. But I decided it was the only way where I could get environmental back then. And so I studied engineering and biology. I worked at an engineering firm on water quality issues. So I never designed the treatment plant with the, how many cubic yards of filter. I was on the receiving end of the pollution. I was out in the environment. Oh, when they discharge that water, was it really clean? What happened to the environment? Should they be cleaning this up? So that's really where I worked. And that was for about 10 years. And then I went to a nonprofit organization called the Charles River Watershed Association, where I worked on the cleanup of the Charles for another 10 years. And that was really exciting because we were just a very small organization with 10 people, but we worked with all sorts of people, including George Zoto, who's on, he's one of the organizers for the Envirothon. So we worked with the state government, we worked with the federal government, we worked with municipalities, anybody we could convince on, I think this pipe here is discharging illegally. I measured it with my, my testing, and that's against the law, and you need to do something about it. And that was sort of and we built a lab, so we did that kind of work. And that was really exciting to see the Charles change over time and improve. And then I went to the government after that. And it's been great to work with all the different agencies. I've worked at 2 different agencies. And as I mentioned, I'm at the Department of Environmental Protection, where George is too. That's been terrific because there are a lot of people that I worked with before are, I'm still working with them, but now I'm on the regulator side. So anyhow, that's my background, and I was very pleased to be invited to speak today. So thank you.
Kathy, thanks so much for participating. Your interest in being a member of the Envirothon team for so many years has been a blessing to our organization. And thanks for taking the time that you've taken today out of your very busy schedule to present. Sorry for coming in late. I just got confused with this Zoom thing. I'm still learning about the process. But if you will, could you answer a few questions? I know that there was one person that asked, when will be the next 100 years?
When will be the next 100-year storm? That's a really great question, and nobody knows. So that's the problem. It just because on average it's a 100-year storm or 1% chance doesn't mean we might not get 2 in a row one year and then the next year. It just means it's a 1% chance, and then the next year is a 1% chance. So it could be, next week. I don't know. Hopefully not, but yeah, it's a great question.
Former watershed team leader, I have to ask this question. As you know, we've built up our watersheds to the point where there's so little infiltration. Just take a look at what's happened along the eastern seaboard of Massachusetts. It's all covered with asphalt rooftops, clay in Situate. You've got bedrock in Hanover. And these people are running out of water. Look what happened with the Situate Reservoir. It just went completely dry. And yet, when you talk to planning boards about the need to mitigate and find ways to put green cover and infiltration where there wasn't and should be, There's so much that planning boards can do, and this is what I think our students should be looking at in terms of how they prepare for this year's theme, which is water management at the town level. I've got a dog, as you notice.
That's fine.
From home. So I would like to have our Envirothon teams to look at their own community from the perspective of the watershed, how it infiltrates water, how it's discharged. What about the stream bank itself, for example? With more rains projected, can we expect the streams will get, through erosion, get bigger? But in the process, we can expect more flooding until that those stream beds can accommodate the water that's expected. What planning boards can be doing through their subdivision rules and regulations, are they sufficient to address new growth, especially further west, where there's still a lot of green cover that should be protected, and the necessity to maintain forest cover when you can, for obvious reasons, carbon sequestration in particular, but the way they recharge water. And of course, you and I can go on and on this stuff.
Mm-hmm. You're raising so many excellent points, George. So, it's interesting because you have raised the issue of municipal planning boards, and the students should recognize, it's very hard to recognize this, that all those development decisions are made at the local level. And we have 351 communities and 351 sets of rules on what can be built and what can't. And so there's a little bit of state authority under our Wetlands Protection Act that gets at development. But really, most of it is local planning. And so, some communities, there are differences in their budgets. They don't all have the same kinds of staffs. They're also at different starting points. So you have some places, like you mentioned, there are some places maybe more toward the west where there's going to be a little bit more real estate, a little bit more room for that river that swells up and overflows the banks for the water to land. And then you have other places like Winchester, where it's really built right up to the Aberjona River, and so there's very little where that water goes is in the buildings. And when I worked at the Charles River Watershed Association, we had a lab in our basement, and when the river flooded, the water came into our lab. So it wasn't like it was a little bit of a puddle. It was as though if you opened the door, you could take your canoe right into our lab. So, obviously that building that was put up years before we got there was not in the right place. And even out in the western part of the state, when you're talking about river scouring, you should, look at the Deerfield River during Tropical Storm Irene. So that was, I think, in 2011. A lot of the riverbank actually ended up in the Long Island Sound because it just scoured and all came downstream through Massachusetts, through Connecticut, and out into Long Island Sound. It's unbelievable, the damage out there. So yeah, how to prepare our communities and use these tools that are available. If the students are looking at their own communities, they may be able to do a GIS analysis, for example, of where's the impervious cover? Where are the opportunities to remove some of that impervious cover? Where are the opportunities to manage some of the water that we're expecting? How can the rivers be able to have enough elbow room, really, to to have that floodplain so that when there's that extra water, they're not the water's not damaging the buildings or coming into the basement of the Charles River Watershed Association's office, but is got a more natural place for the water to be in the floodplain. So I think you're raising some really, really great points. And it would be good to have the students sort of look at their own environment through that lens. You know, where can improvements be made in their communities? I don't know if there are other questions. I see we just lost George.
I think we lost George again. I'm sorry.
Yeah, that's too bad. He was asking some really great questions. We do have a few attendees. I don't know if anybody has any questions, has ideas about what they're going to work on.
And you all could type in the question and answer, or if you want to stick your hand up, I can let you. I can unmute you. Haha. If you'd like to actually talk to Kathy, I recognize all these names, so I know we're in good company.
Yeah, and this is very casual, so it doesn't, you don't have to worry about. I'd love to hear what people are working on if you're, if you know yet.
And some teams really are just getting started on this, so it's fine if you haven't, but if you.
Yep, not a problem.
Anybody has a question for Kathy? Do let us know. So, and I'll babble while people are typing or thinking. If a 100-year storm is, you said now 8.25 inches or something like that in 24 hours, has there been one of those recently in Massachusetts?
Yeah. Well. Oh, go ahead. Sorry.
No, you go.
Well, we had a series. So I showed you. There was the 2006 storm. There were a couple in 2010. So we had a bunch of storms, all in series that were all sort of at the 100-year storm level. So yes, I think the Mother's Day storm was 14 inches over 8 days. So 14 inches is about a third of the rainfall for the whole year normally. And we got it in 8 days. So that was probably even bigger than a 100-year storm.
There's a lot of rain.
Yeah.
We were chuckling. Monday night's webinar was on droughts and managing droughts, and it was pouring rain the entire time. We got about 2 inches here in Holyoke over the day. But so that's not nothing. But
yeah, that always happens when you're declaring a drought. It's during a rainstorm. But that doesn't mean that there's not still a drought. Now we've had a lot of rain in the last few weeks, but people think, oh well, we just had a half inch of rain, so there's no more drought. But sometimes a drought can really last a long time, and even a little bit of rain here and there isn't enough. But I think we've had a lot lately.
Certainly seemed like it. And George is back.
Yep.
The computer died. Of course,
Great.
it would happen while we were on Zoom.
Yeah.
Kathy, the teams this year, as you know, they investigate within their own community, and where they live will vary in terms of what we're asking them to look at. And since it's the Envirothon, they're asked to actually investigate from the perspective of the ecosystem as a whole, in addition to the effects of climate and how water is being more or less of, forest cover, the need to protect, the need to in some way restore in cities. That's the big thing right now. Cities need to have green cover for obvious reasons. Carbon sequestration, more infiltration where there isn't any, cooling of the environment, better lifestyle, better. Things like that. And then of course, habitat. Folks don't like having bears coming into their backyard. But when you provide habitat which is necessary to mitigate from extreme storm events, because they provide recharge. You've got to coexist to some extent. So there's give and take. It's a problem that's really vast in terms of management, because you can't just deal with water alone without looking at its overall effect on the ecosystem that we live in, whether it's in the western part of the state where there's lots of tree cover, or in the eastern part where most of it has been taken out. And so when the students look at their communities in terms of what is and isn't happening, we want them to investigate the soils to the sense of how fit are those soils to adapt to these rainfall events that we expect, so that they can provide adequate recharge. And as an engineer, you know that sometimes you have to do a little cheating in order to do that, by digging holes and filling them up with gravel where you have to, in order to put that water away so it doesn't cause an impact with pollution, with nutrient flows to streams and rivers that are now seeing cyanobacteria loads, bacteria, because of the phosphorus. There's so much to this problem that I hope our teams will investigate, because it'll open their eyes, and hopefully they will see an environmental career that will blossom before them. It's something that, even if you're a mathematician, or it's playing with the numbers, as you know, and what do they mean? Unless you do good data collection, it's not going to have much. But it all has to begin with observations. That's where science can go. So I hope they have fun with this.
Yeah, you've raised so many great points, George. And, I know that this is focused on climate change, but if we don't get the issue of development under control in a way that is sustainable and works with Mother Nature, where our work on climate change really is not going to be helpful, because we have these two drivers. One is the development and how we've changed our landscapes, like you say, paved over our soils, hardened the surfaces, rechannelized or done things to our rivers that aren't expected, and therefore they don't have that floodplain or the elbow room to expand when they need to. Changed the water quality as a result of stormwater runoff and other discharges, so that's affected habitat and the quality of the environment, both on the ground and in the water. There's so many impacts there that if you come along and say, I'm going to address climate change, and you don't address this other piece, you really aren't going to have solved the environmental issues at all.
Yeah.
I think the bigger driver is probably the development and not climate change.
So some of its parts, water is just that one part that can make things very miserable. If the landscape in which all this development is occurring hasn't been properly planned. And
That's right.
for the folks that live on the eastern part of the Commonwealth, it's called adaptation, to promote resilience, because there's a lot of work that needs to be done undoing a lot of that pavement to some extent, while at the same time helping to provide a better way of living.
That's right.
To talk about.
There's so much to talk about. I think we should wrap up now, and thank you again, Kathleen, for being here tonight and sharing all this with our teams. We so appreciate your time and expertise. And George, thank you for all of your comments and questions and wrapping up as well. Yeah.
Thanks so much, Kathy. Appreciate you being with us.
Oh, thanks very much for the invitation. And yeah, I'm really excited about the Envirothon. Great program. So thanks for all you do, both of you.
Thanks so much. Have a great evening, everybody.
Bye-bye.